All right, we're ready. Okay, looks like we're pretty much all here. So, yes, here I am. So anyway, we got only one thing that we will have time for today. We've actually got two things that need to get done though before the midterm. So we have today the chapter 6 problem set. And in the other class, I didn't completely finish it. So I'm sure I won't finish it here either. We'll get close to the end, but not quite all the way. There also, if you look at Moodle, is now a sample midterm posted. And the sample midterm is just a mixture of all the questions from chapters 5 and 6. It's meant to be sort of like an overview of the two chapters. It's also a very good preview of what the actual midterm looks like. So you can see it's not as long as a normal problem set. But keep in mind too, the actual midterm was originally meant to be given in a classroom setting for a period of maybe an hour and a half. So you'll see when you get it that it's not as long as these problem sets, but they do cover all the material. So what we're going to do today is we'll get through as much of this chapter 6 problem set as we can. And then on next Monday, we'll finish it up along with the sample midterm, and then you'll be ready to get your midterm, okay? And you'll have plenty of time to finish it. Don't worry about that. And again, it's just chapters 5 and 6. There's nothing else in there other than that. And then when that's all done, we can start the next section of the course. Beautiful. All right, so let's take a look at, oh, here we go. Who are these? It just says 2 people raise their hands. Britt is one of them. Did you want to ask something? Oh, maybe not. All right, how about Noah?
No, I did. I'm unmuted.
You did? Oh, what did you want to know?
When is the midterm?
Well, the thing is, if I post it next, let's say when we're done on Monday, I'll post it then, and you'll have, let's say, until the following Monday to finish it.
Okay.
Yeah, it's just you download it and you do it at home and you send it back to me. It's not online. I don't think it's even possible to have math questions online with this thing. So it's just you take it home, you work on it, you send it back. It's that simple.
So how do we send it back? Do we like send a picture?
Yeah, that's unfortunately the only option I think that we have. You'll have to get your camera out on your phone and literally just take pictures and send them
Because
back.
showing our work is important, right?
It's very helpful, yes, because if you show me your work and you make mistakes, I can give you partial credit. So it's really more for your benefit than anything else. I'm not going to require it, but I think it's an excellent idea because first of all, it helps you reduce mistakes. And secondly, it gives me the ability to give you partial credit if you get most of a problem right, but make 1 or 2 minor errors. But the only way I can know that is if you show me what you did. All right, so you definitely want to, it's like, think of it as an insurance policy. And since you'll be doing it at home, you'll have plenty of time to do it. So you might as well. In the classroom, I can see you could run out of time. But, in this type of setting, I would say time shouldn't be an issue. So I'd recommend that you do show me your work. I'm not going to require it, but I do strongly recommend it. All right. Well, any other than that, is anyone else dying to know something? Maybe not. Okay, well, that's fine. Then we'll get started. So this is our chapter 6 problem set. Most of these questions are linear, or in some cases, they're all linear, but some of them are equalities and some are inequalities. And then at the end here, we have a bunch of FOIL questions, we have factoring, and we have our old friend, the quadratic formula. So you can see this pretty much covers everything we did in this chapter. These are a little challenging, but not that bad. But we do have to go through a lot of steps though. So like, here's a perfect example. Suppose I told you that there's a math class that has 57 students in it, but it was divided into 2 sections. It was just too big. And so now we are told that one of the sections has 3 more students than the other section. So the question is, how many students are in each section? Now, you could probably figure this one out through process of elimination by trying different possibilities, but let's just do it in a more systematic way. So let's just do this. Let's start out by defining X as the number of students in the first class. And then Y will be the number of students in the second class. One of them is larger. They didn't specify which is larger. It doesn't actually matter. So we know two things. The sum is 57. Okay, that we know. What else do we know? We know that one of the sections has 3 more students than the other one. So let's just assume that Y is the larger of the 2 sections, which means that Y equals X plus 3. All right, now you notice something interesting here and important. We have, and you may have heard this phrase in high school, 2 equations, 2 unknowns, which means we can solve both of the unknowns, which are X and Y. If you have 2 unknowns and only 1 equation, that's not enough. We have to have 2 equations to solve for 2 unknowns. Not a problem. Now, there's a few different ways you could potentially go about this, but I find that most of the students that I've had in the last several years are more comfortable with what's called the substitution method. So we'll focus on that right here. And so we'll note that using the substitution method, we can replace the Y in the first equation with X plus 3. Why is that? Because you can see, according to the second equation, Y equals X plus 3. So in the first equation, since it says that X plus Y equals 57, we'll rewrite that as X plus 3 equals 57. Now look how easy this is. All that we had to do is a little algebra, and we can see that in that case, X must equal 27. And now that we know what X is, we can now find the value of Y by substituting X equals 27 into either of the 2 equations. So let's pick the second, this one, because it's a little quicker. Y equals X plus 3, Y equals 27 plus 3, Y equals 30. So our conclusion to all this is that the first class has 27 students and the second class has 30 students. Now, if you want to double check this, which you don't have to, it's not mandatory, the sum of the 2 classes is 27 plus 30 equals 57, which is what we expect. And one class has 3 more students than the other. Therefore, we must have done it correctly. In other words, there's only one way this could work out properly, and we found it.
Could you throw up? I don't know how you got the 2x when you were solving for, the 2x.
Oh, okay. So here's what we did. I dropped the parentheses here, and I'll add that as a separate line. And then I just gathered together these 2 x's. Okay, and then now, of course, once you're in this spot, you want to get all the constants on one side of the equation and all the x's on the other side. And then when you get to that point, now all I have to do is divide both sides by 2, because I don't want to know the value of 2x. I want to know the value of x. Okay. All right, beautiful. Anyone else? Nice. All right, number 2. For a certain year, the combined revenues of PepsiCo and Coca-Cola were $47 billion. If the revenues for PepsiCo were 11 billion more than Coca-Cola, how much revenue did each company have? All right. Now, let's just arbitrarily assign X to be Coca-Cola And then Y can be PepsiCo. So what do we know? We know that the sum of the revenues is 47 billion. And we don't, by the way, you can leave out the zeros, just call it 47. We know that PepsiCo has more revenues than Coke, so we can say that Y equals X plus 11. All right, now we have two equations and two unknowns. Now, using the substitution method, we can replace Y with X plus 11 in the first equation. Okay, in other words, we know that X plus Y is 47, but we also know that Y is X plus 11. So watch what happens. X plus 11 equals 47. Okay. And we can get rid of those parentheses now. 2x plus 11 is 47. This is very much like the previous one. We subtract 11 from both sides, and now we simply divide out the 2. And that tells me that x must be 18. Well, now that means that we can solve for y by substituting x equals 18 into either of the two equations. So let's pick this one. So y equals x plus 11, therefore y equals 18 plus 11, and I have y equals 29. So therefore, when we're done, Coca-Cola revenues are, that's X, that's 18 billion. And PepsiCo revenues are 29 billion. Now, as a double check, the sum of the revenues between the two companies is 18 plus 29, 47 billion. And PepsiCo revenues are 429 billion, which is 11 more Coca-Cola revenues of 18 billion. So both of the requirements are satisfied. The sum is indeed 47, and PepsiCo, which we defined as Y, has revenues that are $11 billion greater than Coca-Cola. So again, that proves that we must have done this correctly because there's no other solution that would work. All right, everyone's happy? Okay, I'm looking for unhappy faces and I'm not seeing any. That's good. All right. So let's try 3. Now 3 is a little bit trickier because you're being told that the price of this car with the sales tax is $16,665.78. If the sales tax is 6%, what was the price before the tax was added? All right, well, here's what we have to think about. Now, there's a retail price or sticker price to which the sales tax is added. So why don't we do this? Let's let X equal the retail price, also known as the sticker price, and let's let Y be the sales tax. You'll see why I chose this in a second. Because what I want to be able to do is say, all right, well, we know for a fact that X plus Y is the full price that we actually end up paying, $16,665.78. What else do we know? Well, the sales tax, Y, is 6% of the retail price. Okay, so in other words, Y, yes, go ahead.
Never mind. I was just gonna say what to do next, but I feel that I don't want to interrupt.
Oh, okay. Y is 6% of the retail price. And 6%, remember, and 0.06 mean the same thing. All right, so I made a note of this with the other class. Whenever we are dealing with percentages, you should always convert them into decimals. Okay, yes, go ahead, Noah.
I was saying that another thing you could do is convert it into 0.9, multiply by 0.94.
That
If you want to go straight to the answer, you can just multiply by 0.94 because that way is you want to bring it down by 6%, so you'd multiply by 0.94.
Okay. Now that sounds like a good idea, but it turns out not to be a good idea. I'll tell you why. Because if you do it that way, then that implies that the tax was based on the full price at the end, but it's actually being based on the retail price. So if you do it that way, you're not going to get the right answer. In other words, what you're saying is, why don't we just multiply this number by 0.94? And at the end, we'll double check that, but you'll see that that's not going
That would be
to work.
removing 6% of it.
Right, but you see, the problem is it's the 6% is not based on the full price, including the sales
I get
tax.
it now.
It's only based on the retail price. So you're
Okay,
not,
I get it.
okay.
Thanks.
All right. Anyway, so we've got, just like we have had before, we have two equations and two unknowns. Let me just rewrite them one more time. So we can substitute 0.06 for x for y in the first equation. So instead of having x plus y, you'll have x plus 0.06x equals 16,665.78. Now I can consolidate these together into a single term because this is actually 1x. So I can write this as x times 1.06. Okay. Because I have a 1 here and a 0.06 here, I can consolidate them. In fact, you know, let me just add one more step here. And you'll see what ended up happening. So I factored out x from both of those terms, and we end up, when you consolidate those in the parentheses, what you have here is that x times 1.06 is 16,665.78. Now I can just divide both sides by that. Now, one thing we have to note here too is that with a problem like this, we need to round our results to dollars and cents. Okay, because that's how it would work in practice. You're never going to see a price that says like 43.9 cents. It doesn't work that way, does it? No, it does not. So now that's our X. Now this is our retail price. And in fact, we're done with the problem. But what we would like to do is confirm this. Okay, so the sales tax is 6% of the retail price. So you'd multiply that by 0.06 times 15,722.43, and that would give you 943.35, let's say. When this is added to the retail price, the total cost of the car is, and you'll see it's 15,722.43 plus 943.35, and possibly with some rounding issues, it should be the same, 722.43. No, it's correct, 16,665.78, and that is the correct answer. All right, now was that necessary? No, but I think it was a good idea because you've just proven that you've done this correctly. And that feels pretty good, doesn't it? Yes. All right, so far is everyone keeping up? No problems? All right, very good. Now, here's one you've probably seen questions like this before, like especially on the SAT. Lots of these types of problems. You have Pete and Bill. Pete is 3 times as old as Bill, and the sum of their ages is 48 rather. So how old are they? Well, this is another linear problem. So let's let X be the age of Pete. Y could be the age of Bill. And what do we know? Well, the easy part is their sum is 48, but we also know that Pete is 3 times as old as Bill. And therefore, that implies that X equals 3Y. Now, you have to be careful with that part. If you get it backwards, you're of course going to get the wrong answer. Pete is 3 times as old as Y, so we multiply Bill's age by 3 to come up with Pete's age. So we've got 2 equations, 2 unknowns, and then using the method of substitution, we can replace X with 3Y in the first equation. If X plus Y equals 48, let's replace that X with 3Y. And of course, that means that Y is 12. So therefore, we conclude that Pete is 36 and Bill is 12. So for the double check, which again is not absolutely necessary, their ages add up to 48, and Pete is 3 times as old as Bill. Is that what we needed? Yes. And so we must have done it correctly. Okay. Nice. Beautiful. Now, what could be next? Ooh. This one looks very serious. An electric bill. The electric bill for September is $232 less than the electric bill for October, because obviously it's colder in October and you're keeping the heat on longer. If the total bill for the 2 months is $119.56, find the bill for each month. All right, so let's do this. X could be the September bill, and Y could be the October bill. So right off the bat, we know that their sum is $119.56. We also know that the October bill is higher by $232. So why don't we do this? Let's say that Y equals X plus $232. Okay, because it costs more to heat your house in October than in September. And now we can do an easy substitution. Using the method of substitution, we can replace Y with X plus 232 in the first equation. Now, by the way, you can actually go the other direction. You can take the first equation and rearrange it and substitute into the second equation. But our job is to do this as quickly and easily as possible. The fewer steps involved, the less likely you are to make mistakes. So let's do it this way. So the first equation, X plus Y equals 119.56. And now the Y will be replaced with X plus 232. And that, as you can see, equals 119.56. In other words, what I did was I replaced the Y with X plus 232 because we know that they're equal to each other. So I'm going to get rid of those parentheses, and I'll have 2x plus 232 is 119, equals 119.56. I'll then subtract 232 from both sides to come up with 117.24. I'll then divide both sides by 2, and that should give me 58.62. And since X equals 58.62 and Y equals X plus 2.32. Y must equal 5862 plus 232, which turns out to be $60.94. All right, great. So in other words, in conclusion, the September bill is 5862. The October bill, 6094. Now, for the double check, the sum of the bills is 5862, 11956, and the October bill is 232 greater than the September bill. Well, then we must have done it correctly. Okay. Now, what's next? Ooh, now this one's a little more challenging. And I've noticed in the past, people find this one to be not as much fun, let's say, as the other ones. So here's what we have to visualize. You're putting your money in two different accounts, let's say in a bank. Here's account one that pays 8%. Here's account two, which pays 6%. So the question is, how much money did you put in each one? So we'll call this one X, but we don't know. We're figuring that out. Y is also so many dollars. And what we're being told is two things. Number one, half our money went into each account. Well, that means, and this is the important part, since half of this person's money is invested. Oh, before we do anything else, let me just put X equals the amount invested in account one, let's say. Y would be the amount invested in account two. All right. So since the investor put half of her money in each account, that implies that the same amount is in both accounts. So our first equation is that X equals Y. Now, the challenging one is this one. We know that the investor earned 210 total interest from the two accounts. Now, how do we figure that out? So the total interest equals 6% of the amount invested in the first account, or account one, and 8. Oh, actually, no, the first one is 8, isn't it? Yeah, sorry, I got that backwards. 8% of account one and 6% of the amount invested in account two, which equals, now remember, these are decimal or percentages. We're going to convert them into decimals. 0.08 X plus 0.06 Y. And we were told that that adds up to $210. So that's our second equation. All right, so let's just lump them together again, right down here. So using the method of substitution, we can replace, let's just say we can replace X with Y in the second equation. since they're equal to each other, why not? So we'll start with the same equation, and then I'll replace that x with a y. And that tells me that 0.14y equals 210. And therefore, y must equal 210 over 14, or 0.14, which turns out to be $1,500. Okay, now, since x equals y, that means that x also equals 1,500. So the bottom line is the investor has put $1,500 in account 1 and account 2. Now, for the double check, the amounts in account 1 and 2 are the same. Or what you could do is just say that the investor has put $1,500 in account 1 and 2 for a total investment of $3,000. Okay, so with the double check, we can now claim that half of the investor's money, which was $3,000, was invested in each of the two accounts. In addition to that, the total interest earned was 210. So therefore, we must have done this correctly. All right, and we can prove that by showing that 0.08 times 1,500 plus 0.06 times 1,500 gives us $210. Okay. So that one's done. Here's a fun one, sports. All right, now, you believe it or not, yes, Purchase has a basketball team. You may have never heard of them, but they have one. Now, I don't know if they can play anymore with the COVID going on, but they do have a team, or they did have a team. So what do we know? We know that they played 32 games, and they won 4 games more than they lost. Okay, so therefore, why don't we do this? Let's let x equal the number of games that they won, and therefore, y must be games lost. So we know 2 things. X plus y equals 32 because they played 32 games. Now, the number of wins is greater than the number of losses by 4. So therefore, y plus 4 equals x. Okay, because the number of games lost is smaller, we have to add 4 to it to bring us up to the number of wins, which is x. All right, now, using the method of substitution, we can replace x with y plus 4 in the first equation. All right, so the first equation is x plus y equals 32, and that x now becomes y plus 4. So therefore, y plus 4 plus y equals 32. 2y plus 4 equals 32. We subtract the 4 from both sides. Oh, there you go. And now we can find or solve for x by substituting y equals 14 into either equation. It makes no difference. So let's do it this way. X plus y equals 32. X plus 14 equals 32. X equals 18. So the team won 18 games and lost 14 games. So for the double check, we can note that the total number of games is 32. Number 1 and number 2, the team won 4 more games than it lost. So that means we must have the right answer. Beautiful. All right. Oh, now here's an interesting one. We have students enrolling in a school or classes, and we have the years 2017 and 18. So let's let X be the number enrolled in 2017, and Y would then be the number enrolled in 2018. We know 2 things. The total, according to the problem, is 16,983. But here's the tricky part. The number went down between the 2 years. So therefore, and it's not by a fixed amount, it's by a percentage. So what that means is that we can write it in a couple of different ways. You can make the case, for example, that X minus 6% of X equals Y. Okay, but if you do it that way, you'll see that you can actually factor out that X, and you're just left with 0.94X equals Y. So this time you can actually multiply it by 0.94. It wasn't possible with this sales tax formula or problem. So therefore, these are our 2 equations. X plus Y is 16,983, and in addition to that, 0.94X equals Y. So now we can easily use the method of substitution. And let's see, we can replace the Y in the first equation with 0.94X, all right? So that would mean we'd have X plus 0.94X equals 16,983, or it turns out this is equal to 1.94X is 16,983, and therefore we divide both sides out. And whatever this number is the correct answer for X. That would be the number of students in the first year, 2017. All right, now here it's 8754. We have to be careful though, because we have to have an integer here. We can't have a fractional number of people. No, we can't. So then with Y, we already know that Y equals 0.94X. Okay, we can solve for Y by substituting X equals 8754 into either equation. All right, so if we do that, let's do this one. So 0.94 times our answer of 8754. All right, if you take out the calculator, you'll get 8754 times 0.94 is 822. It's actually 822,876, which is rounded to 8229. Okay, so enrollments in 2017 were 8754. Enrollments in 2018 were 8229. So the double check, total enrollments in the 2 years were 8754 plus 8229. And sometimes in cases like this, when you've been rounding, there could be a slight discrepancy when you double check. Just be aware of that. 16,983 though, that's fine. And the enrollments in 2018 are 6% smaller than in 2017. And we can prove it by just noting that 8754 times 1 minus 0.06 equals 8754 times 0.94 equals 8229 when you re-round it. 8228.76, which is rounded, of course. 8229. All right, that one's nice. That one's done. Okay, now this next group are kind of interesting because for the first time we're introducing, at least in a couple of these cases, inequalities. Now here's a good example. We have Mary, who has $8,000 that she can spend on a car. Let's say she got a loan from the bank. It's exactly $8,000. She can't spend a penny more on a car. The problem, though, is that, of course, she can't actually buy an $8,000 car. Why not? Because she'll have to pay sales tax. And in this case, there's a license and title fee of $120. So what we really need to do is figure out, we know that she can only spend $8,000. What we want to know is the maximum sticker or retail price that she can pay for this car. All right, so how does that work? Well, what do we know? All right, well, let's see. Let's let X be the retail price. Okay. Now, how much is the total cost of the car? So the sales tax, 7% of the retail price. The fees are this. So total cost of the car equals X plus 0.07, X plus 120, which we could simplify into 1.07 X plus 120. Now, here's the thing though. This cannot exceed $8,000. Therefore, we have an inequality of 1.07x plus 120 is less than or equal to, hold on one second, I have to look up the symbol for, here we are. $8,000. Okay, so we have a linear inequality. Now, she can spend less than this, but she can't spend more. So the first thing I'm going to do is subtract from both sides the 120. And let's see what I get. And now, of course, I'm going to divide both sides by that 1.07. And again, I'm going to need to round this into dollars and cents. 7880 divided by 1.07 is 7364.49. So that means Mary can afford to buy a car whose retail price or sticker price is no more than 7364.49. Okay, so double check the total cost of the car. We've already seen is 1.07x plus 120. Okay, with a retail price of X equals 8764.49, the total cost would All right. Well, it turns out, except for a slight rounding, it's $8,000. Okay, so that means we've got it. Nice. All right, now, ooh, some averages. Now, this one's a little unusual. What's going on with this one? Bill has 3 test grades, 95, 84, and 85. Not bad, but he wants an A. And let's just say that you can get an A at this school with an average of 90. Now, here's the twist. The final exam is being counted as if it were 2 tests. So what we want to know is calculate not only his average, but we need to know the minimum score he can get on this test and still get a 90 for the semester. So X will be his final exam score. And so his average will be 95 plus 84 plus 85 plus X plus X. If you notice, I'm counting it twice and then dividing by 5, because remember, we're pretending that this is a double exam, basically. Now, the thing is, this has to be at least 90 for him to achieve his objective. So therefore, this is our inequality. It must be at least 90. It could be more, but it can't be less. So now we'll consolidate all these constants and the 2 X's. Wait a minute. Let me just double check that. 95 plus 84 plus 85 is 260. Yeah, 264 plus 2X over 5 must be at least, 90. Now I'm going to multiply both sides by 5. And now the inequality is that must be greater than 450. I subtract 264 from both sides. And by doing that, I get 186. Now, of course, I divide both sides by 2. And there you go. Bill must get at least a 93 on his final exam to earn an A for the course. All right, now for the double check, Bill's average, if Bill gets a 93 on his final exam, his average will be, all right, so we'll plug it into here. All right, and so that equals 95 plus 84 plus 85 plus 93 plus 93 over 5. So if you add those numbers up, what do you get? You get 95 plus 84 plus 85 plus 93 plus 93, 450 over 5, which is 90, and that's what he wanted. Excellent. All right, so now Bill's happy with that. Let's say he gets a 93. Well, now he's jumping up and down because he gets his A. Now, here's 11 is a little simpler. Here's another situation with an average, but this time it's a little simpler because the scores are all weighted equally. Okay, so here's Betsy, who needs a C in her sociology course. That means she needs at least a 70 average. So far, she has a 78 and a 68. If all the exams are equally weighted, what is the lowest score she can earn in the final and still get a C? So if X is her final exam score, then the average for this class will be 78 plus 68 plus X over 3. And here's the inequality. This number has to be a minimum of 210. This has to be equal to at least a 70. All right, so here, this is very simple. In the parentheses, we have 146 plus x over 3. Oh, wait a minute. Whoops. That has to be at least 70. And now multiply both sides by 3. This has to be at least 210. I'll subtract the 146 from both sides. And that leaves me with 64. So Betsy will get a C for the course if she gets at least a 64 on the final exam. Shouldn't be too hard, right? I don't know. It depends on what they're doing in this class, but for the double check, the average is, again, as we've seen up here, these 3 divided by 3. If Betsy gets a 64 on her final exam, her average will be, all right, so you have 78 plus 68 plus 64 over 3 equals, so if you add those up, 78 plus 68 plus 64 equals 210 over 3, which is exactly 70. All right. Now, this one's a little different. This one's kind of interesting, but it's also a little bit challenging because what they're trying to do is, it turns out that they paid $150,000 for this house and they want to make a 10% profit when they sell it. Okay, so the purchase price is $150,000. The desired profit is 10% of that. What else do we know though? So the cost, there's a real estate commission. Now, what we're going to do is let X equal the sale price of the house. Okay, now that's important because the sale price is what determines the commission charged by the real estate agent. All right, so we'll call that 0.07x. That's the commission charged by the real estate agent. There's also a fee of $1,000 closing costs. So the total sale price of the house must be at least $150,000 to compensate them for the original purchase price, plus another $15,000 in profits, plus, actually, let's write it like this. It must be at least, okay, so on the right-hand side, you see the original purchase price, which is $150, plus the profit, plus the commission, plus the closing costs, okay? So in other words, this is the purchase price. See, we don't have quite enough room here to do this properly. All right, maybe we do. The profit, commission, and then these closing costs. All right, so this is our equation right here. All right, so now what can we do? Well, first things first, let's gather together all the like terms. So there's 3 constants in here, which is kind of nice. That makes things a little bit easier. 166,000 plus 0.07x. Okay, now the next logical step would be to subtract 0.07x from both sides, and that would leave me with 0.93x. Oops. Must be at least $166,000. And of course, now all we have to do is divide out both sides by that 0.93, and we'll come up with our answer. Now, again, you may have to round this because of the dollars and cents, but 166,000 divided by 0.93 is 178,494.62, let's say. All right, so the sale price must be at least 178,494.62. Otherwise, they won't sell it. They'll just say, listen, we're going to hang on to it and see what we can get maybe next year in the market. All right, now let's double check it. So the total, the price of the house must be at least, and so remember, we were told it has to be at least this much. If the sale price of the house is, let's see, oh, wait a minute. No, that's not right. Yeah, actually, let's write it like this. It has to be at least this. That's a little cleaner. All right. So therefore, is this requirement met? This number equals 166,000 even. Therefore, requirements are satisfied. All right, now down here, that was it for the word problems, I think. Oh, here we go. Now we're getting into some fun territory. We get to use our old friend FOIL. Now, I'm sure you're all getting pretty good at FOIL. It's one of those techniques that you don't really ever forget, but let's get some done here to get some practice, because practice makes perfect, as you know. All right, so let's remember FOIL. So remember where these are. Here's our FOIL. And last is minus 120. So then often we can consolidate these two terms, not always. Depends on what you're doing, but all right, and so that's the final result. So you just have to be careful. And then there's no reason why you should get this wrong. All right, let's make sure everyone's done. Okay. Well, it's hard to be sure when I only see names up here, but all right, let's just say we should be done by now. And got a few people who are not camera shy, but not many. Okay. I guess that means your room is nice and neat today, or else you've been out of the shower more than 2 minutes. I don't know. Some people just don't like to be on the camera, I guess. I know other people who are doing these Zoom sessions, and I don't know how they pull it off. They're somehow able to call on people, and when they say their names, the camera comes on if it isn't already on. I don't know exactly how that works, but I don't know. And then that way, if somebody, let's say their hair is a mess, we're going to see it, so they have an incentive to get up on time and be there. But I wouldn't do that here. But I just wonder if the technology allows such a thing. In fact, maybe how about, I guess in principle, it would allow us to look at whatever you want us to see. You could show off your room, or you could show off what you have there, your artwork or something. But anyway, let's look at the next one. All right, so same thing, foil. Now, by the way, somebody raised this issue the other day. If you are more comfortable with the box method, which I still don't even know what it is really. I just know that it's a substitute for foil. I know it says to use foil, but if you use the box method and you get the right answer, I'll give you all the credits for it. All right, I don't want it to be too rigid. If you really are much better with the box method, that's okay. All right, don't worry about that. If you do the box, that's fine. I'll know right away if you got the right answer anyway. All right, let's try this. X squared minus 3x, 10x minus 30. Again, we can consolidate these two. And that should be your answer. Now, by the way, I just want to point out, if one of these x's is not x, but let's say x squared or something else, then you might not be able to consolidate these terms. Okay, don't assume that it's always possible to do that. All right, so here we'll have 14x squared minus 18x. The inner one is minus 49x. And last is positive 63. All right, so we're going to have 14x squared. These add up to minus 67x. Wow, interesting. Okay, but that's correct. Very good. Let's try this one. So first would be these two terms. O minus 4x. The inner would be these two. The last would be these two. And that's it. It's that simple. All right, let's try this one. All right, so first would be 15x squared minus 40x, 21x minus 56. All right, so we've got 15x squared These become minus 19x and then minus 56. All right, now one more. Let me jump this down to this page so it's all together in one place. That's better. All right, here we go. First, outer, 16x, inner would be these two. And then finally last. Beautiful. Now, the next batch of questions require us to solve these equations, but with factoring. We're going to save the quadratic formula for last. All right, so it does specifically say factoring, so you really do have to use factoring. You can double check with the quadratic formula if you want, but you do have to show that you know how to factor with these. Now, remember how this works. Just a quick review. If I take x plus m and x plus n, and I apply FOIL to it, oops, what happened there? Look, let's see what happens. So f would be these two, that's x squared. O I and last. So now it's going to be tricky to consolidate these because there's no numbers, or well, at least there's no coefficient. So we'll simplify the middle two terms. And so when you're looking at something like this, what this implies is that what I'm looking for is two numbers, and they have to be integers, by the way, in these cases, or they should be integers. You need two integers, n and m, such that we have a sum of 5 and a product of 6. So what we need to do then, typically the easiest thing to do is to write out a list of all the integers whose product is 6. Like, for example, 1 and 6, minus 1 and minus 6, 2 and 3, minus 2 and minus 3. That should be it. Only one of these, though, has a sum of 5. So 2 plus 3 equals 5. 2 times 3 is 6, so we're good. And that means that x plus 2 times x plus 3 equals our original equation. Now, if you want to, you can prove that with FOIL. I mean, you don't have to. Might be a useful bit of practice. X squared, 3x, 2x, 6. What do you know? It works. But now here's the thing, though. What we're really after is not so much the factors, but the solutions. But it's easy to do that once we have the factors. Okay, so these are known as the factors. But the solutions are obtained by setting these each individually equal to 0. And solving for x, of course. All right, now here's the thing though. How do we know if this is true or not? I mean, we tried our best, but let's say that, I mean, we could have made a typo somewhere or something else. So here's what we can do. Let's double check x equals -2 as one of the solutions. So what you're going to do is just go back to the original equation. And again, this is purely optional. And you're going to evaluate it. Oh, yes, go ahead.
Is it okay if we solve this using the quadratic formula instead? I'm just more comfortable with that.
Well, all right, I'll tell you what, yes, you can for as a double check, but when it does specifically say that you have to use factors, that would be one time when you really do need to use the factors. So
Okay, yeah.
I agree with you completely. It is definitely easier to use the quadratic formula, but in a case like this, you can certainly do that. But
I just did it for all of them.
This has been going on.
Starting at number 19, I just did quadratic formula for all of them.
right. I'll tell you what though, you know, it's easy. If you did that, watch how easy this would be. You came up with x minus 2 and x minus 3 with the quadratic formula, I assume. All you have to do is recognize that the factors would then be, if this is -2, this factor is actually x plus 2, and this factor would be x plus 3, and then that's all you would need to do. So those are your factors. If these are your solutions, these must be your factors. So if you did it with a quadratic equation, you should be able to work it back to the original factors, but you will have to provide the factors as well. Although, yes, I know, I agree. The factoring is kind of a nuisance, but
So, x plus 2 and x plus 3 in parentheses are the factors.
that's correct.
Okay.
Yes. And -2 and -3 are the solutions. And the reason why they're called solutions, and we're going to prove that right now, is that if you plug them into this original equation, you should get 0. And so we're going to prove it. Okay, let's do that. So we have, now what I'm going to do is replace all the x's with -2's. And then we'll have 5 times -2 plus 6 equals 4 minus 10 plus 6 equals -6 plus 6. Oh, what do you know? It's equal to 0. That means -2 is indeed one of the solutions. Now let's try -3. Is that going to work? Well, let's find out. -3 squared plus 5 times -3 plus 6 equals 9 minus 15 plus 6. Oh my God, it does work too. Yes. So basically, we just proved that we were correct. These are in fact the solutions, and these are therefore the factors. Okay. Now let's try this one. We've got x squared plus 9x plus 20. Now we don't have to go through all the steps every single time, but you do want to remember this, that what you're looking for with your factors is a sum of 9 and a product of 20. So let's try looking for the products of 20. You could try 1 and 20, -1 and -20, 2 and 10, -2 and -10, 4 and 5, -4, -5. Now, one of these has to have a sum of 9. Oh yeah, here it is. So therefore, it must be the case that these are the factors of the equation. But remember, our goal here is to find the solutions. And so that's pretty straightforward because all you have to do is set these equal to 0 individually to get x equals -4, x equals -5. And now we get the fun job of double checking. Who doesn't love double checking? It's like when you go to the store and you buy something. Do you double check your change or do you just shove it in your pocket? Oh, I bet I know what the answer is. You should always look in case they gave you the wrong change. It's called double checking. All right, so we'll try x equals -4 to see if it works. Or even better yet, when you leave the house, let's say you've got more than one backpack. Do you make sure you brought the right one? Or do you hope for the best? Well, hopefully you're not one of those that hopes for the best, because sooner or later it's going to catch up with you. The one time you forgot the right backpack, it'll be the day of a final exam or something. And what happens then? All right, 16 minus 36 plus 20 is -20 plus 20. Okay, this one works. And now let's do -5. Is this a good habit to get into? Yes. I know it's more work, but nothing worth having is free, is it? You have to work for everything you have, and this is no exception. Okay, so okay, so they both work. So we definitely have the right solutions with the right factors and the right solutions. All right. Oh, there's plenty more. As if we were worried about not getting enough practice. All right, so remember, again, what we're aiming for is we need the two terms whose product is -12 and whose sum is 1. Remember, there's an implied 1 here. So let's try that one. And let's see. We have 1 -12 is one possibility. -112, then we'll have 2 -6, -2 6, 3 -4, -3 4. One of these has to have a sum of 1, and that happens to be this one. And that means these are the factors. All right, now, of course, we then want to solve. X equals 3, -4. And why not double check? It's good fun, isn't it? All right, so we'll double check whether or not x equals 3 works. Okay, so we'll have 3 squared plus 3 minus 12 is 9 plus 3 minus 12, no, 12 minus 12, 0. Oh, because this x, let's go back here. There's an implicit 1 here. Okay, in other words, the product, remember, a quadratic equation is written like this: ax squared plus bx plus c equals 0. The product is c, and the sum is b. But this time we just had plain x. And so oops. Remember that x means the same thing as 1 times x. So therefore, in this case, this is b, 1 is b, and that's what we need for our sum. All right. Anyway, so, and then we'll do one more double check. We have to check whether or not x equals 4 is correct. And I suspect that it is, but we have to prove it. It's not enough to say, ah, it looks about right. There's no room for that in math, is there? It looks about right. No. (16 minus 4 minus 12 is 12 minus 12 equals 0. Perfect. All right, here we go. Now, how about this one? Oh, by the way, I just want to point one thing out here. You know that the correct form for a quadratic equation is this. If your equation is not in the proper form, you have to rewrite it to get it into that form. And now the reason why I'm mentioning that is because that's about to happen in these last few. If your equation is not written in the proper form, and again, that would be ax squared plus bx plus c equals 0, you must rewrite the equation before either factoring or using the quadratic equation or the quadratic formula. Otherwise, you're going to get the wrong answer. Okay, so in other words, I'm giving you a hint. That's going to be necessary for these last 4. All right, you can see they're not exactly the way they need to be written. You may need to do a little algebra to make sure that they're in the same form or the correct form. All right, so I just want to throw that in there because it looks like we're not going to have time to get past this one. So when you go ahead and finish these at home, just be aware of that. And then at the very bottom, we have our favorite, the quadratic equations. Woohoo! But here the same thing applies. Make sure they're in the right form. Otherwise, you will get them incorrect. All right. So let's try this one, which is still in the proper form. So we need a product of 10, negative 10, and a sum of negative 3. So let's try that one out. 1, negative 10, negative 1, 10, 2, negative 5, negative 2, 5. We need one that has a sum of negative 3. Ah, here it is. And then we can set them equal to 0. Now, once again, we have to prove that these are correct. All right, let's double check. So we'll start with x equals negative 2. All right. Oh, yes, go ahead, please.
On the midterm, will we lose points if we don't double check?
No, not at all. Not at all. This is just for your benefit. It's never going to require double checking, but I would like you to show all the work just as a precaution, because this way I can give you partial credits if something goes wrong. But the double check, you can do that or not. I would never take points off if you don't do a double check, because that's just for your benefit. Unless, if it said do a double check, that would be different, but it won't. I would never say you must double check. Okay, it's not going to happen. All right. All right, so this is 10 plus 10. Whoops, no, it's not. It's 10 minus 10 equals 0. That one's fine. Now we'll double check 5. And by the way, so when we're done, even though we're not completely finished, I'm going to post what we have here on Moodle so you can keep working with it over the weekend and check your results too, especially if you got some of them wrong. We want to make sure we know why before we go any further. All right, so let's just quickly plug in -5 here, and let's prove that we've done this correctly. Oops, something went wrong. Yeah, what did I must have screwed something up. Oh, well, the thing is about the formulas is they are in your slides. So you can use any resources you want on the test. So there's nothing to memorize. All right. Now, if you want, I mean, when we do this in person, I give out a formula sheet, which has some of the formulas, but not all of them. But since you're at home, you can just flip through the slides and find what you need. In fact, you might want to make up your own personal list of formulas so that you'll have it right in front of you and you won't have to waste your time flipping through the slides. But no, you won't have to memorize anything. Oh, well, there you go. The reason why there's a problem is because the answer wasn't -5, it was +5. Well, that explains that. 5 and 5, that's much better. I thought we had a problem here. 25 minus 15 plus 10, or minus 10 rather, is 10 minus 10, and that's equal to 0. So we're done. All right, so we'll save these for last, these last 4 in this section and the rest of these, and for Monday, I mean, and then we'll also do as much of the sample midterm as we can on Monday. I don't know if we'll be able to get through the whole thing, but no matter what happens, you have at least a week to get your midterm done, which is a lot because it's only supposed to take an hour and a half. All right, so, but in the meantime, why don't you keep working on these? And if you want, you could double check your results from today. And if there's no last minute questions, I will see you all on Monday. Okay, all right, see you then.
Bye. Thank you, Professor.
Bye.
Thank you.
Bye.
Bye.
Hi, thank you.